Okay, today we're going to be looking at some more Year 13 pure work, something called separating variables. Now, so far you've looked at how to undo a dy by dx equation as long as it's dy by dx as a function of x, and then we just undo it by integrating. Nice and straightforward. What we're going to look at today is when our dy dx is a mixture of x's and y's, what we have to do is cross multiply, cross divide to get into this sort of situation, where we have all the y's on one side and all the x's on the other side, and then we can simply split up the dy dx, and then we've got the integral of function of y dy equals the integral of function of x dx. We can only do it by cross multiplying, cross dividing. We cannot do it by adding and subtracting. It just doesn't work that way at all. So let's have a look at a few examples of how this goes. So example 1, dy by dx equals x, y. So in this case we've got mixtures of x and y's. We're going to cross multiply, cross divide to get all the x's on one side and all the y's on the other. So what I tend to do is, in this case I want to get the y's on that side, so I'm going to divide by y and write 1 over y, leave the dy there. The other side I haven't touched the x, and cross multiply to get the dx there, and simply put our integral signs in front of each one and integrate it. Integral of 1 over ln y, I can write ln y because they say in the question y is positive, so I don't have to do mod of it, equals, in this case, x plus c. We tend to like y equations rather than ln y. There's nothing wrong with that, but let's have a look at how we tend to tidy these up. We can write y equals e to the x plus c, and a neater way of doing that is writing it as an exponential function like that, because where a equals e to the power c. I can rewrite this as e to the x times e to the c, and since c is a constant, e to the c is a constant, we'll call it big A, and there we go. And that's our exponential equation. And so that would look like that as a differential equation, and when we undo it, separate the variables, and nice and tidy. So a second example, nice and straightforward, another exponential one in the equation though. So let's have a look at how this applies. We're given dy by dx equals e to the minus y, and I put an equals there because I'm looking ahead. I don't like minuses, especially when I'm going to be cross multiplying, cross dividing. There's too many minuses knocking around otherwise. So I'll write it as 1 over e to the y. Put it up there, so cross multiply e to the y dy equals integral. I don't have nothing on the other side, I've got that 1 there, haven't I? So it's nice to write 1 dx. What's the integral of e to the y? dy e to the y. Integral of 1 is x plus c. You know what? I've just realised I made a massive error in the one before. I'll finish this one off first, then we'll go back to the one before. See, I was thinking about this one when I did the first example, and I can say that ln y equals, see, I'm all over the place again. Y equals ln mod x plus c. And I cannot split that up as I did with the one before. I can leave it like that. Let's go back then to example 1. For some reason, I integrated x as x when I should have had x squared over 2. And there, and there, and leave it as x squared over 2. So, without thinking about it, this is what happens. We all make mistakes, don't we? Thinking about the 3 examples we're going to do, I'd forgotten to actually integrate the function there. It does happen to even the best of mathematicians. I'm not saying I'm one of the best, but I don't tend to make those mistakes that often. So there we go. You've got it on camera now, haven't you? So in this case, we integrated 1 to get x, and then we do, since it's e to the y, we wanted to do ln of it to get our function there. And as I say, I can't split this up in any other way. I've got to leave it like that. Third example is set in context. We're given a hot air balloon and its motion, and its rate of increase of height goes down. So it starts off quickly, it's still going upwards, but at a slower and slower rate. So dh by dt equals 20 minus 16h. Maximum height is 1.25 kilometres, and we're asked to find the time it takes to get up from the ground to 1 kilometre. So, as I say, I've got this situation here where I've got this 20 minus 16h. What I don't do plus 16h on the other side, because I've got to get something times by dh there. So what I have to do is divide by all of the function there. And then add by dx there and equals integral of 1 dt. And I've just got to be quite careful with this constant. For some of you, it might be an idea to write this and that. I want the top to be the exact differential of the bottom, and I'm sorting out my constant there. And the integral of 1 dt is t plus c. So I end up with minus 1 over 16 ln mod 20 minus 16h. I don't think I need the mod, but just in case, equals t plus c. And I can times by the minus 16 to get ln 20 minus 16h equals minus 16t, and I'll still call it plus c. It's not the same constant as it was before, but it doesn't make much difference in the moment. And as before, then I can then do 20 minus 16h equals e to the this, or a e to the minus 16t, and I'm sort of off and running then like that, and I can say that h is 20 minus a e to the minus 16t all over, got to be careful now, I should have, all over 16. To help me answer the question, I need to find what a is. So t is 0, h is 0 because I'm starting at the bottom, and I get 0 equals 20 minus a over 16, so a equals 20. And then all I have to do to find the answer is solve it for h is equal to 1. So I'm solving 1 equals 20 minus 20 e to the minus 16t all over 16. Do a quick bit of rearranging. 20 minus 16 is 4. E to the minus 16t equals 4 over 20, which is a fifth. And then get my calculator and get ln of a fifth equals that, and then divide by minus 16 equals that in hours, so it doesn't take that long, and then times by 60 to get just over 6 minutes is my answer there. So t is about 6 minutes to the nearest minute. And so in that case there's lots going on, but notice, as I say, I've got to be careful. I've got to take all of the function there and cross divide by it. I can't do plus minus, because I need to have something, as it were, times by that dh there. And then use the information to find any constants around. Notice, just like the example 1, I finally got there, we've got this idea of how we change the e to the something plus c as a constant times there. Makes it a little bit easier with your working, and that's all there is to it.